All right, you guys. Hello, everyone. My name is Samantha Gibbons, or you guys can just call me Sim if you would like to. And I'm here to be teaching you guys about an introduction to environmental and natural sciences. So, when we look at environmental dilemmas, we first have to understand like the science of it, right? Like the basics. So that's what I'm going to be here for, and I'm going to be teaching you guys just some basic science. It's kind of higher level, but anyone can follow along and anyone can watch. So, today we're going to be talking about the natural world, so the world around us, and the ecosystems that are in there and what it kind of consists of. So, first, let's get to know each other. I know that this is virtual and this is on YouTube, but you guys can still contribute anyway. You can comment your name, your age, where you're from. I'm a big music person, so just to get to know my colleagues a little bit better, I like asking what's their favorite like music or like genre, like song or artist or anything in that realm. And then what you want to learn from this class, you can comment on the YouTube channel. I will be looking through the comments and replying, so you guys can answer those questions. So I'll start with it. And so my name, as you guys know, is Samantha, or you guys can just call me Sam. I'm 16 years old, and I'm from Phoenix, Arizona. My favorite band is the Red Hot Chili Peppers. And from this class, I want to learn more science through my own personal research and from your guys' comments, so I'm really excited for that. And I want to learn more about you guys as well, so I can get to know my audience a little bit better. And just so you guys don't think I'm some inexperienced 16-year-old with all of this, I work at the Arizona Science Center from where I'm from, and a bunch of my coworkers study environmental science, so I really get to have some really like intellectual conversations with them about these really important topics and how they can be applied to the real world. And that's just a little bit about me, and okay, let's just get started. So, first off, what is this course going to be about? Because Introduction to Environmental and Natural Science is a pretty broad term. So let's dive in a little bit about what this course is. So, course description. Introduction to Environmental and Natural Sciences will allow students to be exposed to the natural components of the world around them. Maybe not physically because we are in the middle of a pandemic, but you know the vibe. Ranging from ecosystems to aquatic biomes, so water biomes. There is a multitude of abiotic and biotic factors that shape the way our Earth functions. So, if these terms may seem unfamiliar to you at first, and that's okay because we're gonna define them later in the class. And within this course, an emphasis on the interconnectedness of environmental aspects will be proposed. That is crucial in studying and being a scientist, is that you got to see how everything connects, all these different things that we're learning. And that's really important because that's how we study the world around us. And most importantly, it will be noted how what is being taught in this course relates to environmental dilemmas today and what you guys can do to impact and make a big change in your community or even the world. So, for the course of April, I'm going to be uploading 5 different kind of general areas of this science because there's actually a lot to cover and it's really hard to narrow it down to just a couple of topics. But I thought the most interesting, in my opinion, and just the most beneficial, I guess, per se, were going to be ecosystems, biodiversity, land and water usage, global air circulation and climate, and finally, everyone's favorite, aquatic biomes. And again, if you guys have any questions on what I'm going over, please feel free to comment them down in the comments so I can read them. And if you have any just suggestions or feedback in general, I love it and I'd love to hear it so I can improve and do what benefits you guys because that's what I'm here for. You guys can definitely take notes if you want to. If not, you can just listen and follow along. And yeah, let's just dive into our first unit, which is ecosystems. Okay, introduction to ecosystems. So let's start off with the definition of ecology. So ecology is the study of how organisms interact with each other and their environment. So yeah, that's also a pretty broad term, and there's different ways that we can determine how these interactions occur. So I think just 2 terms that I actually used in the course description are really important to clarify are biotic and abiotic. So actually, this in a lot of sciences you can determine and piece together the terms and what they mean by their prefixes and suffixes. So here's a great example. So right here it says bio, and bio, the prefix means life. So it kind of helps us with the definition, and it's any living organism. Pretty self-explanatory. So some examples, like humans, we're biotic. Plants, they're biotic. Dolphins, monkeys, And then abiotic is the opposite, so anything that is not living or non-living. So that would be like rocks. Rocks are not living. Sunlight, not living. Temperature, I think you get it. Soil, yeah. Okay, so another important term, I think, to narrow it down, I guess, is actually this is kind of a term, but as well as kind of an equation or math. So for all you math people out there, this one's for you. So this term is net primary productivity, also known as NPP because scientists get lazy, and that's how we want to say it. So this is defined as the rate at which producers, and producers, I put in parentheses, are also known as autotrophs. And again, we can use our prefix skills. Auto means like one or to oneself. So they produce their own energy. So plants, they go through photosynthesis. Use photosynthesis to produce and store chemical energy. So they're producing their own energy, right? But that's not going to be us because humans, we can't make our own energy. We have to eat to get our energy. So they use photosynthesis to produce and store chemical energy minus the rate that they use this chemical energy for respiration. So this is kind of a long definition, but it's basically trying to measure how productive an ecosystem is. Because, if we see just like dry land and it's like dead, like that doesn't have a lot of net primary productivity, whereas what's a good place with net primary productivity? Like tropical rainforests. Those have really good NPP levels. So another thing that I wanted to bring to your attention is the trophic pyramid. And it's pretty easy to understand. It can be a little overwhelming at first, but that's why I'm here to explain it. So I'm just going to break it down. So on the first level of the pyramid, we have the producers, like I said over here, the autotrophs, the plants that produce their own energy. So we have like grass, we have flowers, all that good stuff. And, they can produce their own energy. So they're going to be at the bottom of the pyramid. Preceding that, we have the primary consumers, which, as it sounds, they're the first type of consumers, so they eat these plants, and that's how they get their energy. So a good example of these are rabbits or bunnies. They do get their energy from eating plants and grasses. And then the level above that is secondary consumers. So the secondary consumers are what eat the primary consumers. So a good example of this would be snakes. They would eat the bunnies. They wouldn't just eat the grass. And then finally is the tertiary consumer, also known as an apex predator, and they're at the very top. So that would be like a hawk, an eagle, and like a polar bear. Those are some examples. So those are the different levels. And then we see these 6 arrows in the middle, and that represents, as it says, the energy being transferred. So the grass is being transferred to the bunnies, and that's energy. The bunnies' energy is being transferred to the snakes, and so on. But then additionally, we have these 3 arrows at the outside of the pyramid, and this represents the energy lost. And shockingly, 90% of the energy is lost as heat. So environmentalists have this rule called the 10% rule, because 90 plus 10 equals 100%. And actually 10%, only 10% of energy is genuinely transferred that we receive. So that's really not that much in retrospect, which is pretty crazy. So I have a question for you guys. You guys can comment below. What level do you think humans fit into? I'll give you a second to think about it. I wonder. Okay, it was kind of a trick question because we can fit into multiple levels. It just depending on where you eat. So for instance, if you're going to be like a vegetarian or vegan, you're not going to be a secondary consumer because you're not going to be eating meat. Whereas the vast majority of the population is going to be a secondary consumer or a tertiary consumer. So it really just depends. Any level except for producers, because again, we don't go through photosynthesis. That would be kind of weird. So yeah. Okay, so we're kind of jumping around here, but we're going to talk about what even is air. That's probably a really weird question, or what chemical is it mostly composed of? Because we all know what air is. It's the thing we breathe, right? But what really is it? So, 78% of our air is nitrogen gas. It's actually not oxygen, which is a common misconception. So approximately 80% of the air that we breathe is nitrogen gas, and that 20% ish to complete the 100% is oxygen. So it's really a relatively small amount. And then there's also a 1% of just random gases that aren't really as relevant, but they're still there. And then I don't know if you guys study chemistry, so I just put a Lewis dot structure just to show nitrogen if you wanted it. All right. So next, continuing on from nitrogen, since that's such an important aspect of our air, since it composes the majority of it, we're going to talk about biogeochemical cycles. So again, this is a very long term, and for people that aren't really familiar with it, it can be a lot. So I'm going to break it down with the prefixes. So bio, again, means life. Geo means like rock or earth, like geography or geology. And then chemical, I'm assuming you guys all know what chemicals are. So the living, rocky earth chemical cycles. So pretty much everything. It's literally every science combined. So there are four primary biogeochemical cycles, and the first one I'm going to start off with talking about is the nitrogen cycle. Because, again, the majority of our air is composed of nitrogen gas. So, this is a very complex cycle, and it's kind of hard to explain in such a short period of time. But basically, it consists of the air in our atmosphere. When we as humans die, or other animals die, and their bodies decompose in the ground, there's going to be something in the soil called, they're little microorganisms or little bugs called nitrogen-fixing bacteria, so they're bacteria, and they basically break down or decompose our body using a bunch of different chemical processes like ammonification, and they really use like ammonia and stuff, but I'm not going to go too much into detail with that. But they basically break down our body, and then they recycle those nutrients, that nitrogen nutrients, back into the atmosphere, and that's how that cycle kind of flows. So it's really important. So the next one I'm going to be talking about, the one you're probably more familiar with, is the carbon cycle. Again, this one is pretty complex. It has a lot of different aspects going into it. But, so where should we start? We can start in the atmosphere, right? So in the atmosphere, we have a bunch of carbon, from automobile emissions, from fossil fuel emissions, from industrialization, mechanization, just all of that stuff. And then we have the trees that take it in, and other plants that take in the carbon dioxide, so that's a source of it. The largest reservoir of carbon is actually in the ocean. That's really important to note for later. And, so the trees, they take in that carbon, they go through cellular respiration and photosynthesis to produce, they don't go through cellular respiration, they go through photosynthesis to produce oxygen so that we can breathe. But then we also produce oxygen through cellular respiration. So this is kind of basic biology, but that's kind of how it flows. So the next one is going to be one you're probably not as familiar with, is the phosphorus cycle. Phosphorus is an element on the periodic table. It's number 15, I believe. I believe it's number 15. Don't quote me on that. But it's a very important chemical, and it's a very important cycle that we go through. So what's really important to note, that a key aspect is that it does not have a gas phase. Like nitrogen gas, carbon gas, those are gases, right? But phosphorus doesn't have a gas phase. And its primary reservoir is in rocks, specifically sedimentary rocks, and that's really important to regulate these different aspects of our environment. And then finally, the last one is the hydrologic, which is a fancy word for water, cycle. This is the one everyone knows by heart since like 4th or 5th grade. So here's kind of a more complex diagram of it, because normally we just think of like evaporation, transpiration, precipitation, condensation, and all that good stuff. So, I'm just going to start right here in the water storage in the oceans, because ocean is water, obviously. So, we're going to have that evaporation occurring, so that liquid transferring to gas. And then we're going to have the clouds that form. And then we have the water storage in the atmosphere because clouds are just water in a different form. Then we're going to have that precipitation, and then after the precipitation, what we normally don't talk about generally in the water cycle is runoff and infiltration and groundwater storage and groundwater discharge. So, what happens? Say, for instance, we're on a mountain, right? So, we have snow here supposedly, and the snow melt runoff goes into streams. And runoff consists of not only that water, that form of water, whatever it is, typically liquid, it also is going to carry different like stuff that it comes on the way. So, like rocks, gravel, and just they call it discharge. And it's going to infiltrate, so go into places where there's going to be other forms of water, so it goes back into the ocean. All right, so I thought this quote was really important regarding ecosystems, and it was said by Chief Seattle. Man does not weave this web of life, he is merely a strand of it. Whatever he does to the web, he does to himself. And this guy right here, fun fact, Seattle, that's actually how Washington got its capital, was named after Chief Seattle. And he was born in 1786, and then he died in 1866. But what he's saying in this quote is that man does not weave this web of life. It's not us, it was already here for us. And he's merely a strand of it. Because, humans have only been here for like that long on a geological time span. So whatever he does to this web, whatever we do to the earth, he does to himself. So I think this quote is really important because it really just goes to show that humans have a hard time thinking long term rather than short term. And we're going to do what's best for us now. However, we really need to take into consideration the long term effects that we are going to be having on the planet. Because if there's no planet, there's no humans. And that's sometimes a hard concept for people to grasp. So comment down below your thoughts on this quote, and if you guys have any further elaboration to go with that. Okay, so this is just something that I wrote. This is from me. This isn't a quote or anything, but I think it's a good wrap-up. So the world is composed of a multitude of ecosystems. So it is necessary that we reflect on what we learn, so just being educated, and think about long-term consequences, as I said previously, that can arise from this knowledge. So that's a main reason why I'm teaching you guys this information, is because we always hear about in the news like global warming's occurring or climate change, but it's like, what's really happening? What's like the scientific background information that we need in order to gather data and figure out what we can do from here on? And just really conceptualize these things, that this information, and just doing some research and just understanding why these things are occurring and what we can do to prevent it, because the more you know, the more you can discover. Oops, okay. So, what can you do? The big question that everyone's probably wondering. So, I'm just talking about in retrospect to ecosystems. These are just two things that I came up with. So recognize that balance of species is crucial to sustain a healthy ecosystem. So going back to that trophic pyramid, if the grass or the producers go away, then what's the primary consumers going to have to eat? So they're going to die off. And then what's going to happen to the secondary consumers, since their prey is going to be dead too? So it's really important to make sure that these things are balanced in order to create a healthy ecosystem, because then, if it's not balanced, it causes something called trophic cascade or ecological cascade, which is never good, because then that means the whole ecosystem and the whole environment just goes out of balance, and then lots of exponential increases and decrease, and it's very bad. So making sure that we can balance out these species and recognizing it, right? So then we also want to avoid disrupting these naturally occurring cycles, so the biogeochemical cycles. An example, like, it's so bad if we do disrupt these cycles because they're naturally occurring, and so it's really hard to get them back on track once we do it. So the carbon cycle, that's a really good example, is if we keep emitting more carbon into the atmosphere than can be replenished back and go into that cycle, then it's going to be thrown off, and then we're going to have an overabundance of carbon in the atmosphere, and then we'll be dead. And then what's a good example? Oh, the water cycle too. If we use more water than we can replenish back into the environment, then we're going to run out of water, and then we're going to die. So, yeah, these are really life-threatening outcomes that are really important. So that's why it's important to understand these naturally occurring cycles. And then the biggest concept is to think long term. I don't think I can repeat this enough because, again, it's really important to think long term rather than short term because, well, if you're watching this video, you probably already do think long term. So you might want to share it with your friends who think short term and just think of, oh, this isn't going to happen to me, but the data shows otherwise. And the people that cannot think long term, it's not going to work because we really need to think of what's best for our future, especially since I don't know who's watching, but I'm 16, so it's going to be my generation that's going to be the ones to have to change and fix all the stuff that the past generations left for us. And with all of this, as I say, makes a happy earth. If we take all of this, I know it's a lot, but if we take it into mind and just keep it in mind and just try to be more eco-friendly and just think about these naturally occurring cycles and healthy, just like keeping the animals and the whole environment, both abiotic, the non-living and biotic factors, in check to make sure that we are good, that we are sustained, or the earth is being used in a sustainable way, and so we are living in sustainable circumstances. So with all of that, I thank you for watching this, and I will be back next time, and I hope you guys learned something new. Okay, bye guys.